Hello, grade nines. So today we're going to start with physics for term 2, and we are going to be looking at the booklet on force, work, energy, and power. So on the first page of the booklet, you will see that there's quite a nice introduction there. Whereby we are going to be looking at mechanics, which is defined as a branch of physics that deals with the motion of material objects. The term mechanics generally refers to the motion of large objects, whereas the study of motion at the level of atoms or smaller is a domain of quantum mechanics. So this is just a brief introduction. You don't need to know this in too much detail. It's just to show you that we are looking at motion and we are looking at how different physical quantities relate to motion. So mechanics is also defined as a branch of physics that deals with energy and forces and their effect on the bodies. So please make sure that you read that little section at the top of the page, and then we are going to go on to the definition. So what exactly is force? Force is that an object moves when a force is applied to it. So this is defined as a push or a pull. So there's a little box on your page, and it shows you need to just fill in there that it is a push or a pull that is going to change either the direction or the acceleration of an object. The object could decelerate, which means it could slow down, or it could speed up based on the force. Now, grade nines, our SI unit for force is going to be in newtons, which is a big N. So you can put that big N on the side there for yourself. On this slide, you'll see there's a few examples of what constitutes a push and a pull. We have a man that's pushing a pram with a baby in it. A pull can be seen when you switch a light on, or when you actually pick something up from the ground, could be a pull, as well as when you switch the lights on at night. So just have a look at that little picture there on the side and those examples. And then you'll see that there is a little picture on the right-hand side showing a robot that is pushing a box up an incline. And those labels there with the diagram, with arrows, are showing the different types of force. So you have an applied force, which is the push. You have gravity. Gravity is can be abbreviated as Fg, also known as weight, because gravitational acceleration pulls the mass down. Friction, there's a frictional force, that's the opposite of the applied force, which is push. And then you have a normal force, that is a force that is put on stationary object. And we're going to go through every single one of these in a little bit more detail as we go through the section. So for now, I just want you to fill in your definition, and then we'll carry on going into non-contact and contact forces. There are two types of forces that we are going to look at this level, at grade 9 level, and that is going to be your non-contact forces and your contact forces. And it's very, very simple, grade 9s. A contact force is going to be something that requires touch. It's when objects are touching each other. A non-contact force acts across a distance, and there's no touching involved whatsoever. So in the little picture there on the side, you will see there's a few examples there. Contact forces would be an applied force, a spring force, a drag force, frictional force, and a normal force. And like I said before, we're going to go through all of these, so please don't stress, okay? And then the non-contact force is an attraction or a repulsion over a distance. So when I say attraction, repulsion, what's going to come to mind for you? You're going to think of electricity, you're going to think of electrostatics, or you're going to think of magnetism, as well as gravitational force. And we're going to go into a little bit more detail of weight and gravitational force a little bit later. But for now, all you need to know is the two different these types of forces and the difference between the two. Okay, gravity. Let's look at gravity. A gravitational force, like I said before, it can be abbreviated with the Fg. And this is a force which all objects with mass exert on each other. The downward pull of the Earth on all objects is considered the gravitational force. It is also referred to as the weight of an object. So gravity pulls you down to the Earth, and it is exerted on all objects that have mass. And we are going to look at what is weight versus mass. And you guys need to know the difference between these two, because a lot of the times people get confused. Mass is measured in kilograms. Force or gravitational force is measured in newtons. Okay, so please make sure you highlight that. Have a look at the pictures on the page. Make sure that you, maybe on the side in the margin, just make a note for yourself that mass is kilograms and gravitational force is in newtons. Electrostatics. So all of you should be quite comfortable with this at this stage. And as you know, what is the law of electrostatics? Like charges are going to repel and opposite charges are going to attract, and this is a non-contact force. As I said before, it is a repulsion or an attraction. The force that electrically charged objects exert on each other, the force may be attractive or repulsive. Remember that, and please highlight this, like charges repel each other, and unlike charges are going to attract each other. Just like with the hair example, if all the strands of hair are charged with the same type of charge, what's going to happen, grade 9s? They're going to separate, okay? Versus if you have two different charges, they're going to attract each other. So in the example we have on the slide, we have a comb and little pieces of paper. The paper is attracted to the comb. You should be very comfortable with this. You shouldn't have any problems with it. Please just highlight the relevant issues, the relevant parts, and understand that electrostatics is actually a non-contact force. So magnetism, I don't think we got into a lot of magnetism in the last section for electricity, but magnetism is when the two magnetic poles exert a force on each other. So if you have two poles that are the same, what's going to happen? They're going to repel each other. Two poles that are the same are different. They're going to attract each other. The magnetic force, the electromagnetic force of the Earth is very, very important, grade 9s, and especially, I don't know if any of you have learned this in geography, but there's a link at the bottom, and you guys can look at the Earth's magnetic field and how this influences everything, life on Earth, and how things actually operate life as it's in a nutshell. So please have a look at that link. It's a nice little extra. Maybe it will help you understand this a little bit more. But we've added these little sections in your notes to make you just identify that the magnetic force is non-contact. Okay, so this is a bit of a new force. You guys wouldn't have experienced this yet or learned about this yet. This is called normal force, and this is a contact force. We abbreviate this with a big F and an N that is in subscript. So please have a look at that at the top of the slide. Maybe just write that into your notes. It should be on page 2 of your notes. And there's quite a few there's 2 examples there of normal force. Normal force is the perpendicular upward force. So what is that? 90 degrees upward force exerted on an object by the surface on which it rests. So I want to give you an example of that would be if you put your cell phone on your desk, okay, there is a normal force that is exerted on that object, and it's always 90 degrees from the object. So whether that object is on a straight line or whether that object is on an incline, that normal force is always perpendicular, always 90 degrees. And we are going to test you on this. We're going to see if you understand that definition. So look at the pictures that we have there. We've got a box sitting on a table. What forces are at work on this box? We've got the normal force, which is represented as a straight line up from the box, and then you have the gravitational force, which is pulling the box downwards. So it's going to be opposite from the normal force. Please look at the object on the inclined plane. We have the normal force, which is completely 100% 90 degrees from the object, okay? And then you're going to have your opposite force from that object. I don't want to go into too much detail regarding gravity right now because we're gonna look at that a little bit more detail when we go through weights. But the most important thing, and I've said this and I know I'm repeating myself, is that it's perpendicular from the object. Okay. Okay, another new concept for you is frictional force. Now, friction depends on the surface. So if you are pushing an object up the hill, for example, or you are pushing it up an incline, it all depends on the surface, because some surfaces provide more friction than others. Think of an ice skater. Right? An ice skater moves effortlessly across the ice. Why is that? Because the frictional force is a lot less than the applied force. There is not a lot of friction there. Versus the road or the tarmac, there'll be more frictional force. Okay, so that paragraph over there, I want you to read that very, very carefully and slowly. The force is caused when one surface moves relative to another surface and always acts in the opposite direction to that in which the object moves. So it's always opposite to the applied force. Look at the man that's pushing that box. That man is applying a force, but there is friction also involved to slow that box down, depending on the surface that he is pushing the box. There's also a little slide at the bottom of this particular slide that shows the types of friction. So kinetic friction, what does kinetic mean? Kinetic means movement, the energy of movement. So when the force is applied to an object and the object moves. So examples are sliding friction, okay, rolling friction, and fluid friction. And you'll see there's 3 examples there of these different types of friction. I want you to add this into your books, like maybe make a little note on the side just so that you see that there isn't just one type of friction. Okay, so we're going to go into tension next. We're almost done with contact and non-contact forces. What is tension? Now, tension is the force caused on an object by a string, wire, and rope. So the object is, a force is being applied to that, the force is being applied to the object by the string, the wire, or the rope. So guys, this is not a pushing action, this is a pulling action. So if I were you, I'd look at that little picture of that tug and war. Those 2 people are in the middle of a tug of war. And what's happening there is there's lots of forces that are at play. We've got gravity, we've got normal force, frictional force, and then we've got tension, and that tension is being applied, okay, because of the pull. That string is pulling. And the tension usually is going to be focused in the middle because of the tug of war. Look at the picture next to the tug of war. You'll see that there is a mass that is being suspended from a string. Where's the tension force? The tension force is being applied upwards from the mass. And then another example would be, if you look in construction, you've got a force exerted by a rope, a cable, or a chain, and that force is moving upwards from the string. Okay, so I hope this makes sense. We don't really go into too much detail with tension at grade 9, but you still need to know what it means. At the top of page 3, you will see a heading of air resistance. Now, air resistance is it's dependent on the mass of the object as well as the surface area of the object. So if an object is falling, so let's look at that guy with his parachute, okay? Gravity is pushing the parachuter down. He is being pushed down. The air resistance is opposing the gravity. It's trying to push the parachuter up. Now, if the gravity and air resistance is equal, okay, that the man is going to move at a steady pace, okay? However, if the gravity is the gravitational force is higher than the air resistance, he's going to move quicker. Why is that? The mass of the object is going to influence the gravity, okay, and the surface area. This usually a human being is quite heavy. Versus, let's think about a feather, guys. If you drop a feather from a height, what is going to happen? It's not going to move that fast or move downwards that quickly. Why is that? Because it's super light and it has got quite a large surface area. So what's going to happen? The air resistance is going to fight the gravity of the feather. Let's look at the parachute over here. We've got the parachuter has now, there's definitely some air resistance or drag. We call that drag. I want you to remember that for lift. And then we've got the pull. However, if you think of that parachuter, he's moving very, very quickly down towards the earth. And then all of a sudden, he will pull that cord and the parachute will come out and he will slow down. Why is he slowing down? Because of the air resistance. And there's so many other things that come into play here, grade 9s. There's so many other things. There is the wind speed. There are the conditions of the environment at the time. So sorry about that, the dog is barking. There's the conditions of the time. So, but for now, you just need to know that air resistance is the force that the air particles exert on the object as it moves through the air. The force acts in the opposite direction of the motion. Another type of contact force is buoyancy or buoyant force. And this relates to density from last year. This has got to do with a fluid force. It's got to do with the force that comes from the pressure exerted on an object by the fluid. It is an upwards force. Just like air resistance is an upwards force, if you think of the parachute that it's falling down, it's the same thing. Yeah, now depending on the mass of the object. So let's think of a rock and a beach ball. If you throw the rock in the pool, what's going to happen? The rock is going to fall down to the bottom of the pool. If you throw the beach ball in the pool, what's going to happen? It's going to float on the surface. Why is that? Because the mass of the ball is a lot, the mass of the beach ball is a lot lower or a lot less than the rock. So it is going to float, as well as the surface area of the beach ball is larger than a small rock. So that force of gravity is, for the rock, definitely higher than the buoyant force. If a buoyant force is higher than the gravity, then what's going to happen? It is or greater than the gravity, it is going to float. Okay, so this is an upwards force and is present regardless if the object floats or sinks. So just because the rock is at the bottom of the pool, grade 9s, doesn't mean that there's no buoyancy there whatsoever. It's still acting on the rock. Okay, it's still happening. So let's look at that example. You've got a boat, and then you've got a little a mast piece or a block that's right at the bottom of the river or the ocean or wherever this picture is depicting. And that block is definitely heavier than the boat. This relates to density as well. The density and buoyancy work together quite a lot. So we're going to stop now. I'm going to go on to the last slide, and then we'll be done for contact and non-contact forces. The last contact force that you guys need to know about is called lift. Okay, so this force opposes the weight of the object. So this is what causes that aeroplane to lift in the air. Look at that picture we've got there. We've got drag, which is also known as air resistance. We've got thrust, which is what? Thrust is applied force. Then you've got weight, which is gravitational force. And then you have lift. And those are 4 forces that are acting on the airplane. Okay, so This force directly opposes weight of an object, but is not the same as normal force. Why? Because the object is moving. This is a mechanical aerodynamic meaning moving force produced by motion of the object through the air. So if there's no air particles, there's no lift whatsoever. So more motion, okay, or no motion, no lift. So if you have a lot of motion, you're going to have more lift. So I want you guys to be able to differentiate. So you need to know the difference between lift and normal force. Normal force is a stationary object. The object is not moving. Lift is the object is moving. There's a little picture on the side that I've pasted into the slide, and it shows how lift and Bernoulli's equation works together. So what is Bernoulli's principle? It's got to do with pressure. And we're gonna go into pressure a little bit later in the term, or perhaps next term, but the two work together to get the airplane off the ground. All right. That is it for today. Oh, that is it for this part of the lesson. The next part of the lesson is going to carry on with weight, and you're going to see just how you can actually apply an equation to figure out what the weight is of an object.